Welcome to Project 16B. In this lesson today, it's just a continuation of radial line development, and the part we're looking at in front of us is you're seeing the Orthographic Multi-View, top, front, and right side. And what this is it's just like a cone, but this was something that you've seen a lot back in the earlier times at gas stations. They used to have these paper oil cones there for you to use, and we're going to take and I'll show you how to do a development of this, how to make a flat pattern. And basically, like I said, it's just a cone and it's got an angle cut on it, and you can see from the top up here's the hole, this right here is the hole here, and then down on the right side. So truly, when you start drawing this up, it's just like what we did in Project 16A. Alright, you've got to use this formula to find the complete angle, and again, you've got to find what the true lengths of the lines are. That's what dictates all of it, is this formula and the true length of the line. Okay, so let's start out with this, and first thing I always want to do is I'm going to put a line across here, and I want to extend these lines up to it. We'll do us a trim. So at this point, this would be the original cone before it was cut all the way up. So we need that to start off with. Alright, and I need to find what the true length of that line was. So it's 6.6874. So again, R is for radius down here of this, and we'll find that by really quickly hitting radius. I think it's 1.5. S is the side, the true length of the line, which we just got, and then it'll give us our total angle. So we just need to grab a calculator real quick, and I want to zoom in here so this will make it a little easier to see the numbers. And again, 1.5. 1.5 was the radius, divided by 6.6874 equals, and then you times that number by 360. You end up having 80.749 is what we'll say. 80.749. So what we'll do, I should have left it up, or 80.749, divide that by 2, and equals 40.3, let's say 40.375. And put me a line over here to start with, straight up and down. And I want to set my polar tracking to 40.375, and then hit OK. So again, we're coming off the bottom here, up 40.375, and then I want to take and I want to mirror. I want to grab this whole thing, I want to do a rotate. Straight up and down just like that. Or actually, I'm sorry, I've done it the wrong way. It needs to go around the other way. So that's no big deal. Mirror. We'll go about this axis, because this one's going downhill, so this would go downhill. Y'all see that? I'll clean all this up. So again, I'd like to go back and check my calculation just to make sure. 1.5 times, or sorry about, divide by this number here, 6.6874 equals times 360. That gives your total angle 80.7488. Okay, and let's check out our angle, make sure we're right. 80.74, 80.7488. That's close enough for what we're going to do. And it's good to check yourself, to double check before you get too far along and have to go back and redo a lot of things. Alright, we've got that set up now at this point. Now, I want to take and move this thing. I want to catch this point. That's the vertex. I want to line it up with this vertex right there. Like that. Alright, now, first thing that we're going to look at, and we've got that measurement off our vertex, and what you're going to do is this length of this total length here. Let's go ahead and figure that out. So come up here, grab your radius, go off your vertex with it, and then type it in at 6.6874, and that use the radius, the circle radius, and that gives us this from here to here. It gives us this line here. We'll trim off all the fat off of it. Okay, at this point we have the cone made. Looks like a big Dorito or a piece of pizza, but that's a flat pattern of this cone. The second thing we need to do is we need to figure out how the shape is going to be in here to match this little cutout. Now, to do that, if you look, you have to make yourself an auxiliary view. Okay? And that's exactly what we did here. I've already made the auxiliary view, and that's things we've done earlier in the semester. So make yourself an auxiliary view, and then on this auxiliary view, we got to make us some numbers so they go around it. Okay? So hit your, and of course, we need to put our numbers up here too, and let's go ahead and do that. I'll put me a line in here to get started. And we'll do an array around this thing. And I'll use 8. Go around that thing 8 times like that. And when you do that, this right here would be number 1. This line would. This line here would be number 2. This line right here would be number 3. This line would be number 4. This line would be number 5. Be catching that outside edge. And so on. And then when we come over here, if I split that thing up 8 times, again, we could hit array, polar array, catch this side here, catch the vertex, and again we got to figure out what that angle was in there to put this in, and I've got it right here. It was 80.745 is what we said, so be 80.745, enter, and change the direction of it. This was split 1, 2, 3, 4, 5, 6, 7, 8 times. And this is split 1, 2, 3, 4, 5, 6, 7, 8 times. Even though on that array I had to put 9 items, but it actually let me split it 8 times evenly. So that's what I want. Of course, this right here would be like this one's number 1, comes down. Whenever it turns to the right side, this is be number 1. That's represent number 1. That's number 2, number 3, number 4, number 5, and so on and so forth. Now that's a good way to keep everything in balance. However, whenever you come up here and we're going to try to put this one in, it's going to have its own lines. I'm just going to delete these out for the time being. and I want to do an array around those. Polar array, and let me do this. Let me just go in there and put a point right there. Now you don't have to put a point in. You can just put a line in. I'm just putting this to make it a little bit easier for me. And I can grab this point, polar array it, grab it there. We need to have 8 of them inside of this. So now you just got to keep it. So this point right here, this right here is number 1, right there. Okay. This line right here comes down perpendicular to this. That's number 2. Make it a little easier for me. Sure, I got my note on too. Catch that, bring it straight down here, boom. Space bar to repeat my command, boom. And then this one, of course, is going to catch that outside edge. So this one will be 1 for me. This will be 2, 3, 4, 5, 6, 7, 8. And again, these numbers will be the same. This is 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 would be the point, or not 9. This will be 1. I'm sorry. That's whenever they fold back around on each other. So at this point, what you're going to do is, you remember how I talked about you had to have the true length of lines? All you're going to do is hit a line, come from the vertex down to this point. It has to be aligned to this point. And I need to set that on. To this point. That's 2.5828. So that would be the line. And what I always do is I just use a circle radius and type it in. 2.5828, enter. Come over here and grab the vertex first and then type it in. 2.5828, enter. And I'll grab myself a point. Put it right there. And after you get that point in, get rid of that line, or that circle that we put in. Now, I'm going to delete that off and go up here and grab my next point. From my vertex, I'll come down here to this point. In a straight line, that one's the vertex, this one's 2.4807, enter. There's my next point. Alright, get rid of that circle. Go in there again, do your alignment, go from the vertex down to that point, and it needs to be in alignment now. And that is aligned right there. So come back over here, take your circle, circle radius, and that radius was 2.2677, enter. And make sure you grab your point, put it right there, get rid of that circle, get rid of this number. Again, grab alignment, go from your vertex to this point, 2.113, grab you a circle right there, 2.11, what did that say? 2.1133. Now I'll just go to properties and fix that real quick. Radius was 2.1133. Enter. And I grab myself a point. Come in there and grab that right there. And then my last point that I need will be from the vertex to this point. And that's 2.0. 2.0697. Enter that in. I'll get rid of this one I had before. Put my point in. Get rid of that. Now, all I have to do is go ahead and draw myself a polyline. Grab this node to this node, to this node, to this node, to this node, and then we'll take and just do a mirror image. Well, first, let's do this. Let's do a polyline edit, PE, enter, grab that line, do a fit, get it smoothed up a little bit. Now let's do a mirror, grab that, right here in the center, this should be right in the dead center of this thing, enter. Alright, now I just go up here and format, I turn my point style off, just go up here and do the blank one, OK. Just do a trim. After we've trimmed it all out, this is what we've got. And when you take this and print it, if you've got a printer, and then take and turn it, fold it into it, and we also need a seam for it. We'll put this little seam on here. Run it down. I'm just eyeballing this, but enough to glue it. We should be able to take and seam that all together, and